When we talk about system level thermal solutions, we're referring to equipment and accessories utilized to reject the heat generated by system components to the exterior environment. That's usually the ambient condition. Ambient design conditions can be anywhere from -50 to 140 Fahrenheit and 0 to 10,000 feet elevations for terrestrial systems. In some cases, there may be a chill water infrastructure, which would be the exterior environment we would reject heat to, for example, shipboard chill water or a facility chill water system. So the first thing we need to understand is the design criteria. What are the heat sources? Electronics are going to be a big one in pretty much every system these days, and they're going to be sensible heat. That may be a very continuous load, or it could be transient in the case of directed energy systems. Occupants may be present in the system, and they provide both sensible and latent heat loads that need to be addressed. The envelope of the system allows conduction from outside temperatures to inside, as well as additional thermal loads that come through due to solar radiation on the exterior skin of a system. Outdoor air may also be a load in the system if we're going to be providing fresh air for pressurization and making sure any leaks in the system leak out, as well as ventilation for the occupants. Once we know what the loads in the system are, we also have to understand what we're trying to maintain in the system. So what are the acceptable conditions? For electronics, that's usually an entering air temperature to the electronics. With occupants, it's more of a average space temperature that's being controlled. 60 to 80 degrees Fahrenheit is kind of a reasonable range for that. Relative humidity below 60% is also usually required. Traditionally, we don't get into adding humidity because of the logistical issues of providing a water source and maintaining a water source to keep the humidity levels